Right, so students, hopefully before this video, before watching this video, you already attempt example 10 and also 11 in our notes. Alright, so example 10, 11 are two passive questions that we take it out, and then you realize that besides the iteration formula chapter, they actually involve some other chapters knowledge as well for these two examples. Alright, so when you try to solve these two questions, if let's say there's any part or any question, any part that you don't know how to solve it, or you already forget about the concept, I will prefer you to look back to all the parts that you are not so sure. So you can treat this as a revision for you. All right, because you see that all the chapters are linked together, and then if let's say there's one particular chapter that you are not sure about the concept, then generally it's quite hard for you to continue. All right. Okay, so okay, I will start to discuss the example 10 first, and I will assume that all of you already attempt the questions. Okay, so this is a diagram given, and then they tell you some details, all right, about this diagram and so on. Okay, so here they said what is the angle? The angle AOB. AOB is alpha radian, and then the alpha is between 0 and pi over 2, and so on. BN is perpendicular to OA. So generally this paragraph discuss about this figure here given. All right, okay, and then I think there's one important sentence here, which is the area of the triangle OMB is half the area of the sector OAB. Alright, so when you look at this question, generally this is the question that they give you in a very useful information that you will use it later. Alright, okay, so first they want you to show that alpha satisfies the equation in the equation sign 2x equals to x. So they want you to prove this equation actually. How can I get this equation? Generally, you need the information given in the question earlier to lead you to this final equation that they want you to prove. Alright, so that's why I said the previous example, the previous sentence here is very important. Okay, so what is it? They are saying that the area of the triangle OMB is equals to half. Half means half, okay? The area of what? The area of sector OAB. All right, so this is where you should start with your information. All right, and then if you look at the area of triangle OMB, so for the triangle OMB, the area, this is a right angle triangle. So if let's say you want to find the area for this triangle, you can write half the length of ON multiply with the length of NB. Agree? And then half, just copy the half, area of the sector OAB. So if let's say you're looking at the area of the sector, so you know that the radius is r, right? So area of the sector means half r square theta, or r square alpha in this case. Okay, so now the problem is I want to know the ON and also the NB. How can I find the ON and NB that is related to the alpha and also the r? Okay, so now I would like to use this triangle to show you. Okay, if you focus on this triangle, you will know that if let's say I'm having sine alpha, so sine alpha is equals to NB or BN over R, opposite over hypotenuse, right? Therefore, your NB or BN is equals to R sine alpha. So you are going to substitute this into your equation later, into your steps later. So the same thing happened. I'm still referring to the same triangle, and if I look for cos alpha, so what is cos alpha here? It will be ON divided by R. So ON is equal to R cos alpha. So again, I will want to substitute this equation, okay, into my solution later. Alright, so from here you can see that I try to link the NB with the variable given in our graph, which is R and also the alpha. Okay, so I will continue from here. Half, I will just copy it as half. ON means that I'm having R cos alpha. NB means I'm having R sin alpha, which is equals to 1 over 4 R squared alpha. Alright, so if I simplify everything, I'm having half R squared sin alpha cos alpha equals to 1 over 4 R squared alpha. Okay, so if I look at this equation now, I can try to simplify some other things, some things here. So R squared and I squared can be simplified. Okay, and then 4, maybe I will bring it up to the other side, and it will make it become 2 sine alpha cos alpha equals to alpha. And eventually you have sine 2 alpha equals to alpha. So how I know that sine 2 alpha is equals to alpha? So from here to this one, again, you need some knowledge from chapter 3, the trigo identity. So there's a double angle formula for sine, right? Because you know that sine 2 alpha is equals to 2 sine alpha cos alpha. So that's why I say if let's say possible, you try to memorize all the identity. It will be very helpful in solving some question in our past year. Right, so in the exam. So generally, you need to, if you can memorize, then automatically you will know. You can straight away apply. All right, and then here you can show them also that, okay, since sine 2 alpha equals to alpha, that means alpha satisfied the equation sine 2x equals to x. So this is the answer for our first part here. Okay, so again, how I start? I will just start with the information that they provide in the question. Then from that, I slowly substitute everything into the R and also alpha. Then simplify it, you can get an answer. All right, okay, so in this part, you will see that you need some very basic knowledge in AS, which is the area of triangle, area of sector. And after that, you need the knowledge from chapter 3, A2 chapter 3, the trigo identity. Alright, so all these are linked together, so make sure that you know everything here. Okay, so this is what we have for part number 1. Okay, then after that, if let's say you continue to part number 2, they want you to sketch a suitable pair. So again, this comes out again, a pair of graph. They want to show that this equation has exactly one root in the interval. Alright, so again, you need to spend some time to learn how to sketch graph. So there are two graphs that I want to sketch. The first one will be sine 2x. Another one will be sine x. Y equals to x. So these are the two graphs that you need to sketch here. Okay, so for me, I will just sketch it out for you. There's no steps that you need to list out. You just need to sketch it out only. Alright, so I'm having my sine 2x graph. And the interval that they want to show is from 0 until 90 degrees, which is pi over 2. Alright, so if I sketch pi over 2 until pi over 2, my sine graph will be something like this. This is pi over 2. Okay, and then the maximum point here will be pi over 4. Okay, so this graph is actually y equals to sine 2x. So if you already forget how to sketch the sine 2x again, spend some time, go back to chapter 3 trigo chapter, and then do some simple revision on sketching the sine 2x graph. Or maybe go back to AS chapter 5. Alright, so we learned all these basic technique before, just that we seldom apply it. Alright, so you just need to take some time to recall back. Okay, then y equals to x is a very simple graph. So y equals to x should be something like this. So this is y equals to x. Okay, and then you will see that you get one intersection point. Okay, so you can say that you have one intersection point. Okay, then there's only one root between 0 until pi over 2. So this is how you use the graph to locate the root. Okay? So I hope that there's no problem for you. Okay, so maybe for the graph y equals to x, some students might have question. Maybe some students will ask me why the y equals to x cannot be like that. Okay, or maybe why cannot the y equals to x like that? Can or not? Also one intersection point lah, but y it must look something like this. Okay, so maybe before you draw the y equals to x, you can actually try to substitute in the value one, because this is pi over 4, right? So at pi over 4 here, this value is equals to 1. Okay, so this value is equals to 1. So when I sketch, I know that at the value pi over 4, okay, the line y equals to x will be at pi over 4 also. So I know that my y equals to x will pass through this point and 0, 0. So when I connect it together, this is my graph, how my graph look like. Because pi over 4 should be less than 1. Okay, so you need to have some small common sense here, all right, to get the answer. Okay, all right, so this is how we get the answer. And then for part number 3, they want you to use the iteration formula, okay? And then the initial value is x1 equals to 1. Find the alpha, correct to 2 decimal places. Show the result of each iteration. All right, so here I will substitute 1 into our equation. So our iteration formula will be sine 2 multiplied with 1. So which is sine 2. And your answer should be 0.9093. So again, if you cannot get 0.9093 as your answer, then just double check and see whether you are having the R mode or not, the radial mode in your calculator or not. Okay. Alright, then after that you can continue with x3, x4 and so on. I'm not going to show you all the detail here, but you just make sure that all these are 4 decimal places. Okay, all the iterations are in 4 decimal places. For me, my case, I try until x9. So x9, I get 0.9492. And then I also double check with the x8, x7, and I realized that the value for 2 decimal places is actually already constant. So for the root, it should be 0.95. So how many iterations you go through is not important. The most important thing is all the iteration you put it in the decimal places that they want, and also write out the final answer root, okay, for the accuracy that they want. So for this case, they want only 2 decimal places, so which is 0.95. Alright, so this is what we have for part number 3. Okay, so I hope that all these small details that you already forget, please make sure you go and do some revision on it. Alright. Okay, no one can help you. Only you can help yourself. If you don't want to do revision, then generally it's quite hard for you to continue, or maybe it's quite easy for you to make some mistakes. Right. Okay, so let's continue to example 11. Okay, so they give you one equation here, and they only focus on x greater than 0. Okay, so find the coordinates of the stationary point of the curve. And you need to determine whether is it a maximum or minimum point. So for this example here, it is actually differentiation question, because they want you to find the stationary point, right? And after that, some more they want you to determine whether is it positive or negative. Alright, so I will start with differentiation first. Okay, so since I know that y equals to log x plus 2 over x, so 2 over x means that 2x power negative 1. Okay, so to find the stationary point, I need to do the differentiation, dy dx. Differentiate log x, I got 1 over x. Differentiate 2x minus 1, I will get negative 2 over x squared. Alright, so all these details, please make sure that you go back and do some revision how to differentiate all these functions. Okay, so the next step, after you find the differentiation, you let dy dx equals to 0 to get the x coordinate. Okay, so for me, I will combine these fractions together, the fractions together become x minus 2 divided by x squared. So x squared cannot be 0 lah. The denominator cannot be 0, right? So you only can consider x minus 2 equals to 0, and you get one stationary point, which is x equals to. Okay, so do you need to find out the y? Yes, because they're asking you to find out the coordinates. Coordinates means both x and y. If your x is equals to 2, then what is the value for y here? So your value of y will be 1 plus log 2. Or you can change it become 3 significant figure if you want. Alright, but I'll just keep it like this first. Okay, so once I know the coordinates already, then they want me to decide whether is it maximum or minimum. So to decide whether is it maximum or minimum, there are two methods also. So for me, I realized that for this example, it will be easier if let's say I find out the 2y dx2 dx squared. If you want to draw the table, also can, up to you. Alright, I lazy to draw the table for this case, so I'm just going to do the differentiation. So for my differentiation here, I will just continue from this part, from here. Okay, so if I continue with the differentiation, then I will get negative 1 over x squared. Okay, then I will get positive 4 over x power 3. So all these are basic differentiation. After that, I substitute the value of 2 because my x is equal to 2 now, right? So you substitute the value of 2 into the d2y dx squared. So you're having 2 squared plus 4 over 8. And then you will have the value 1 over 4, which is more than 0. So greater than 0 means that this point is a minimum point. Okay, so after you decide everything already, you get everything already, then you just write a conclusion. So 2 and 1 plus log 2 is a minimum point. Alright, so very obvious for this first part, you realize that everything is about the differentiation chapter 4. Okay, alright, then after that, we continue to the next part. Part number 2. So they said that the sequence value of values given by the iterative formula is this one. With the initial value x equals to 1 converge to alpha. So here, this sentence, they already tell you that this iteration formula will give you the approximate root. They already tell you that it is converged to alpha by using the initial value x equals to 1. Okay, then here they say state an equation satisfied by alpha and hence show that alpha is the x coordinate of a point on the curve where y equals to 3. Okay, so actually what they want you to do in this question is they want you to show that this iteration formula, okay, can be rewrite into the original formula, but the value of y is a 3. Understand or not? So they actually want you to prove either original to this iteration or from the iteration to the original formula. Okay, so that's the meaning of this question. Alright, okay, but they already mentioned here when y equals to 3. Okay, so it depends on where you want to start. No, you want to start from original to iterative, or iterative to original also can. Both also accepted in marking scheme. Okay, so you don't need to worry about it. Alright, so I will start from the original. So 3 equals to log x plus 2 over x. And then if I look at this equation here, I realize that I will want to move the log x over. And then if I bring the x up and 3 minus log x down, then this is the iteration formula that I can get. That's it. Okay. Alright. Then after that, for third part, they want you to find alpha correct to 2 decimal places, showing each result of the iteration. So again, for this question, they didn't tell you how many decimal places you need to show. Okay, for all the iteration here. So by default, we will just write it as 4 decimal places. Okay, so I will have x1. So x1 is equals to 1. To get x2, you substitute the 1 into the equation, the expression on the right hand side. So you'll get 0.6667. And after that, no need to write out the formula anymore. You can straight away press calculator. Okay, try to find out all the iteration here. So again, I am not going to show you all the detail of the iteration for my answer. Okay, for me, this example, I get until x7 up, so which is 0.5583. And I also double check it with all the previous value for S6 and X5. I realized that it is constant at 2 decimal places already, where the root is 0.56 for this case. Okay, so this is how we get the answer for the root. Alright, so from example 10, 11, I hope that you roughly have the idea of how they usually ask you for all the questions. You will see that they will try to put in some knowledge from other chapters. Alright, okay, so here we ended our chapter 6 for A2 syllabus. Then in the next video, we are going to start with the new chapter already. So new chapter, we are talking about differential equations, where you need to use all the integration technique that you learned before. So before you proceed to to chapter 7, sorry, please make sure that you are very clear with all the integration technique in chapter 5. Alright, so I will see you in the next video then.